So these are the basic commands. CLC is for clearing the command window, then CLF for clearing the figure window, and then clear all is used for clearing all the workspace variables. And then here I have defined some few more variables which we will discuss later. And this is how we define a matrix in Matlab. See, if the same matrix needs to be defined in C++, I think you need a for loop, a double for loop rather. But see how easy it is to define a matrix using Matlab. So let us see. Let us first run portion of this program. So I am not going to run these three statements. So I select these and press Ctrl R. Now their color has changed to green. So that means these statements will at present will be treated only as a comment, not as a MATLAB program statement to be executed. These will not be executed. These are only the comments. So I want to run the program up to this end only. So here I define some I write some undefined variable, let's say z. So that the compiler will stop at this point and will not move further. So I press F5. So this is the first step which generally comes if you are working in a different folder. So MATLAB is asking to run this file, you can either change the MATLAB current directory. So this is what is generally done. So I do change directory, click over here, and then MATLAB will run this program. So here what should come out? A matrix defined as per this format that should come out on the command window. So you can see here A is defined over here 10, 20, 30, 40, 50, 60, 70, 80, 90, and after that it is giving an error message undefined function or variable z. So that is this is I am doing it knowingly just to make sure that the complete program is not run, it is only run step by step up to a particular point only. So you can make a better screen presentation also here. Let me set the annotation tool over here and this one over here, this one over here, and this end up to here, and this is the command window side. So I am placing it this way. So I can see both the windows simultaneously, side by side. Okay, so now what I do, I remove this Z from here and place it over here. So now let us run the program F5, pressing F5. So it is giving an error in this program. This is the program name MATLAB underscore introduction underscore 2020 underscore 10 underscore 04. You can use underscore in the MATLAB file name but not space. And the error is in this file at line number 15. So line number 15 is over here. So here what I am doing, I am saying figure number. That figure means I want to draw this. I want to draw a figure now. I am just telling the computer that its figure number should be given by a variable fig underscore no. But it is saying that that is not defined, undefined function or variable fig underscore no. So that is why this is because I turned this statement into a comment. So I select this statement, press Ctrl T. Now fig number variable has been defined. It is equal to 1. So let us see what happens now. Press F5. So here you have got a 3D bar graph, right? So how do we get it? On the command window, nothing is appearing except A. This A can also be you can make it invisible, not to be shown over here. So for that you can add a semicolon at this stage, right? Over here if you at the end of this line, if you add a semicolon, then this a will not be shown in the command window, although it is there in the workspace. So again I press F5, you can see now that a matrix is not being shown in the command window. That saves our time as well as command window space also, and this is the output which we are getting. So here what I am doing, bar 3, I am using bar 3 command, which is used for drawing 3D bar diagrams. Bar 3. If you want more details about this command, you can simply type help bar 3 and enter, and it will tell you all the details related to bar graph command, bar 3 command, which is used to draw 3D bar graphs. So basically bar 3, then within the bracket there is y comma z. It draws the columns of the m by n matrix z as vertical 3D bars. So or here we are using this format, bar 3, and in the bracket there is z. It uses the default value of y equal to 1 is to m and 4 vector inputs, right? So these details you can study from the help, and it will also suggest to you how you can draw other types of graphs, 3D graphs also. So you can see this command also, bar 3h, and then 2D graphs bar h are also available. So it will show you some similar commands also which can be helpful to you. Okay, if someone needs in his or her thesis this kind of graphs, this kind of graphs, 3D graphs, so their only thing is that you must be aware that these kind of graphs can be drawn using Matlab very easily, and you can use such graphs to make your thesis more interesting. So here basically what has been done, this title is written first, right? And then this is the X label. Title is, you can see over here, this is the title of this graph. I have used the title 3D bar graph, and command used is bar 3a. So here this is what I have written over here, title, and within the round bracket rest of the details are written. And then there is X label, then within the round bracket whatever you want to write as X label, that is written. For example, here I have written column number, so this is X label, here column number appears. Then there is Y label also, on Y label you want to write row number, so that is written within the round bracket, and it is there is an extra comma also over here, apostrophe, yeah. So similarly you can write Z label also as Z value. And then there is a command pause, and here it is basically if you want to pause for some time, so you can mention the value over here to pause for some seconds. So pause seconds, at present it is 0, so no wait at all. If you want computer to pause for some seconds, you can add some value here. G input value is also 0. Z input is let us change it, right click, uncomment, or you can type control T. Now let's make it 1. Now see what happens. I press F5 and okay, it is saying undefined function or variable pause second. So let us uncomment this also first. Uncomment, then press F5. So now you can see it is the computer has changed the cursor to a selection format, right? So it is asking for me to click on this figure somewhere, click on the screen. So once I click on the screen, then it will move further. Now the compiler is at line number 23 and it is asking for a graphical input. So after I click, then it will move further. Then it will come across this Z variable which is not defined, and then it will tell me the error that there is an undefined variable Z. So I repeat, uh, let us make this pause seconds as 10. Now let's see what happens. Pressing F5. Now it is waiting for 10 seconds. 5, 6, 7, 8, 9 and 10. And after 10 seconds, it goes to line number 23 and it asks for a graphical input. So it is waiting for the graphical input from user side. And now after I click on the graph somewhere, then it will go to line number 25, and where it will find an undefined function and it will show an error that there is an undefined variable Z. Now for there are some other interesting graphs also, like now I'm moving Z to the next stage. So here you can see this is figure number equal to figure number plus 1. So that kind of statement can be easily used in Matlab, very widely used. So it is basically at present figure number is 1, right? Value of figure number variable is 1. So that is what I have defined here. Now even if I click in the workspace over here, this is a figure number variable. So I double click over here, it will tell me its value. So that is 1 at present. So when I tell the compiler that figure number equal to fig number, so here the value of fig number will be stored, will be mentioned. So will be assumed by the Matlab compiler. So it will be 1. Then there is plus 1 also. That means the figure number variable will, after executing this statement, figure number variable will be equal to 1 plus 1, that is equal to 2. And now I am drawing a second figure. So for that I am using figure, then within the round brackets I am mentioning figure number. So second figure will be drawn. And okay, let's see what happens. Pressing F5. This is figure 1. It is waiting for 10 seconds. 6, 7, 8, 9, 10. And now it is waiting for the graphical input. I click on the screen, then it moves further. Again it is at line number 36, again waiting for a graphical input. I click again and then it goes to line number 38, and here you can see undefined variable Z. So this is a stem diagram which can be drawn easily using stem3 command in Matlab. So here also similar method is used. Title is written, X label, Y label, Z. Okay, let us now make this graphical input G input value to 0 and the pause seconds also to 0. Now let's press F5. Now this time it is not waiting at all. It is not pausing. It is not asking for graphical input because I change the parameters pause seconds to 0 and G input value parameter also to 0. Okay, here you can see I have defined a kind of sub matrix, you can say. So at present we are having a matrix A, which is this 10, 20, 30, 40, 50, 60, 70, 80, 90. Now I define another sub matrix out of it. I say small a1, that is equal to A, and within the square bracket I mention the element numbers like 1 first row, comma, all elements, right? Suppose to make it more easier, I say a naught a0 equal to a, and that is equal to a1 comma 1. That means a first row first column, so that means this very value, that is 10. So let us write Z over here and see the press F5. Now I want to see the value of A0, so I simply write here A0, enter. So it is telling me that value of A0 is 10. If I write here 2, 2, and remove this semicolon so that it should automatically show me the value in command window, I press F5, and in the command window you can see okay, it has gone away. So let me type again A0, enter. It is busy somewhere, yes. Okay, it has taken some time to calculate that. So A0 is equal to 50, and that is second row, second column. So if I make it 1, 3, that will be first row, third column. So what will be the value of A0? That will be now first row, third column. So that is 30. So value of A0 will be 30 now. Pressing F5. Close. So here the value of A0 is shown, that is 30. Now suppose I want to draw some other submatrix such that we should have all the columns and first row only. So A1 is a submatrix of A which is having first row, right? First row, comma, this semicolon means all the columns. So that means A1 will be a row matrix 10, 20, 30. So press F5. Okay, now write here A1, enter. So now you can see A1 is 10, 20, 30. You can see it through the command window, or you can also see it through the variable editor available from the workspace. So you can look through the workspace also. This is A1, 10, 20, 30. And similarly now A2 is this is A2, second row, all columns. So I press F5, and here you can see this is A2, 40, 50, 60. And similarly A3 can be evaluated, that will be third row and all the columns. So pressing F5, so you can see here, over here A3 should have appeared by now. So here the Matlab compiler is busy, you can see here busy is written. So it is still calculating the values. This time it is taking very long time. It should not have taken that much. So here you can see A3 is there, 70, 80, 90. Right? So now I have A1 as a row matrix, A2 as a row matrix, and A3 as a row matrix. Now I want to define another row matrix which should be like it should have all these values in a single row: 10, 20, 30, 40, 50, 60, 70, 80, 90. So for that what I do, I say A equal to, then within the square bracket I mention the matrices, sub matrices A1, A2, A3. So let's see the effect here. Remove the semicolon, press F5. So here you can see the effect. This is A1, then A2 is placed 40, 50, 60, and then at the end A3 70, 80, 90. So here actually this is A1, this portion, this is A2 40, 50, 60, and this is A3, and this is placed exactly as mentioned in this statement. A is equal to, then first place A1, then A2, and then A3. Okay, again I go for drawing the next diagram. So here I say figure number, increase the figure number value to 3. So that is figure number equal to, over here it will be 2 plus 1, so that becomes 3. Now I am gonna draw the figure number 3. So here I am using the command bar. So let's press F5. This is a two-dimensional bar. So bar command, you can use it for drawing these kind of 2D bar graphs. How to draw it in detail, that you can take help, and it is very easy to use command. You will need only 5 to 10 minutes for learning this command in detail using help. So only thing is, you need to write help in the command window and write bar and press enter. You will get all the details also, and you will get some sort of examples also. So these examples you can simply copy paste into your Matlab program, run it and see the effect. And it will also tell you some similar commands related to bar, like hist, used for histogram. Float is a very basic command which is used in Matlab. Then other commands are also mentioned. Okay, again I go for the next diagram, pressing F5. So this is a 3D surface graph. You can see here a 3D surface graph, and the command used is surf. It's not surf, it is basically surface, shortcut of that, surface, right? SURF stands for surface, and three-dimensional surface. So you mention X vector, Y vector, and Z also. So here this is X, Y, and Z, and it is also showing some scaling display also. So depending upon the value along z axis, when it is largest, the color over there is red, and when it is smallest, the color over there is blue. So it can be related to stress also sometimes, floating stress graphs, or it can also be related to strain graphs. So when the strain is minimum, there the color is shown as blue, where the strain is maximum, the colors are shown to be in red. Or it can also be related to thermal graphs also, where the temperature is high, it is shown in red color, low temperatures are shown in blue color, and in between some different color variations are used. Okay, again there is another very interesting command, that is mesh. So how to draw this color bar? This is called as a color bar. This is drawn using this command, color bar. So once you write color bar, it will show this vertical color scale. If you don't write color bar, that scale will not be shown. So now again pressing F5. So here in this diagram you can see a 3D surface graph is also shown. Here this is a 3D surface graph drawn using SURF. And in the second plot, subplot, better speaking, it is a subplot. So here I have used mesh C command to draw a 3D mesh graph. The surface is a little bit different from the mesh, and in this mesh graph, this is basically you can say mesh is a kind of a woven fabric, you can say, right? And here on the bottom surface you can see these contour diagrams also that can be drawn using this mesh C command. So on the base you can draw contour diagrams also. Okay, you can also draw animated plots using Matlab. So let me press F5 and now you will see an animated plot. This is sometimes required to make some interesting presentation. Again, the corresponding matrix values are same as well as I have used for drawing other previous surface graphs. Only thing is, just to make it more interesting to the audience, you can use some kind of this kind of animated graphs also. Although while drawing the other static graphs also, the Matlab compiler works at the backend into this format only. It calculates different values and then one by one draws each and everything. But it does it so quickly that it appears to your eye that this has been done single hand at just one instant. But using animation, we can show the creation, this kind of creation also. Okay, let us see another graph over here. Okay, this is gonna take much time, so I am just closing it. So I just press Ctrl C to stop that animation in between. Control C is to basically terminate the whatever is Matlab doing, just to stop it in between. So you can type Control plus C, Control C. So let me first convert this animated graph plot into a comment statement and now pressing F5. So the compiler is busy. So here basically what is happening first, this time axis is defined between 0 to 100. This is a row matrix, then it is converted into the form of a vector. Then sinusoidal displacement signal is evaluated, then that displacement signal is plotted. It is still busy. Okay, let me press Ctrl C here. So operation terminated by the user using G input at line number 80. So where is line number 80? It is over here. G input at 80. Okay, this is the function actually related to G input. Let me close this. Okay, let us close this also. Control R. Make turn these statements into comment. I do not want to see these old figures again and again, so I press Control R here, then Control R over here also, and then here I will see the output. So pressing F5. So this is a sinusoidal response. You must be wondering, I am calling this linear line segments based graph as a sinusoidal input. Yes, it is actually a sinusoidal input. Only thing is the sampling rate has been very small than what could have been better, right? So if I increase the sampling rate, then I think we can get a better display of these results. So what I do, I instead of 10 over here, I make it 1. Let us see the effect now. Now somewhat it is looking like a sinusoidal curve. Now let's make it 0.1 and pressing F5. Now it's looking perfectly as a sinusoidal curve. The thing is that actually if your sampling frequency is very small, then that kind of problem which we just saw, that kind of problem occurs in signal processing, not only in this theoretical results but experimentally also. If you do not set your sensor sampling frequency properly, this kind of problem will be there in the signal processing. When you experimentally measure the signal also, such kind of problems may arise if the sampling frequency is not good enough. So there is some specific criteria, Nyquist criteria, based upon which the sampling frequency is selected. It depends upon the what kind of frequency you are gonna measure. So here let us first go into this. Here this statement is defining a simple row matrix. So let me copy this from here, place it over here in the command window and press enter. So see the effect. This is what is the effect of this statement. A T matrix, row matrix is defined. Its different uh, elements are such that the first element is 0 and then there is an increment of 10 till the value reaches or crosses till the value is about to cross 100. So first element is 0, then 10, and then there is every time an increment of 10. Ultimately it reaches 100 and then the compiler stops there. Now it is a row matrix, right? But we generally prefer to work using vectors. So we simply say T equal to T transpose, right? So here this apostrophe comma is actually working as a transpose. So when I say this T equal to T transpose, so immediately the computer converts this the previously row matrix into a column vector by taking its transpose and stores it into the same variable T. Now I say I define a for loop. So here is an example of for loop over here. So for that you can see, let us create a new file, clc clear all clf, and then T is defined. Okay, then I define for loop for I equal to 1 is to 1 is to 100 x I comma 1 is equal to I, and then end. Press F5. It will first ask you where do you want to save your file. So let us save the file as for underscore loop save. So see the output, this is the output, right? So what is happening? Initially it calculated T, okay, that was actually not required. So anyways, then it calculated I. So I was started with 1, then an increment of 1, then up to 100. That means I was a row matrix containing values from 1 to 100 with an increment of 1. And then the computer comes over here. So what is over here? X. So that means there is a variable x whose first row first column will be equal to I. So at present for during first looping, so I will be 1, so I x is equal to 1, that is defined. Then it again goes back on the top of the loop. Then during second time I value of I will be 2. So here actually I will not be a row matrix. I will not be a row matrix. Here I will be a only a variable. So initially at first instance I will be 1. Then computer will come across this statement. It will say x1 comma 1 is equal to 1. So that is clearly written over here. Then computer goes back to the top of this for loop. Then it gives I an increment of 1. So that I becomes 2. Then it says x2 comma 1 is 2. That means second row first column of x is equal to 2. second row, first column of x is equal to 2. So it makes x into this format. Then again it goes back on the top of the loop. This for looping is very important. It is very much used in assembly operations, in defining the elements, particularly very useful in assembly of finite elements. So then third time I will be equal to 3, and then it comes over here and the compiler says the third row first column of x will be equal to 3. So it takes into this format, x turns into 1, 2, 3, and so on. In next iteration it will be 1, 2, 3, 4. In next iteration x will be 1, 2, 3, 4, 5. In next iteration it will be 1, 2, 3, 4, 5, 6, and so on. Ultimately I will be equal to 100 and x will become equal to 1, 2, 3, 4 up to 100. So this is the value of x which we are getting. Now if I want to plot it, let us plot x comma x. Now see the effect. Now pressing F5, and this is plot of x, and on y-axis also there is x. Let us define some y variable over here on y-axis. So I say y is equal to, y I comma 1 is equal to I square. Now pressing F5. It is plot x comma x. I must change it to x comma y and pressing F5. So here you can see the effect. This is x changing from 1 to 100 and y changing from 1 to 10,000. That is square of x, right? So this is a quadratic function. If you want to draw a cubic function, then just write 3 over here, press F5. So this is a cubic function. And if you want to draw multiple complex function, let's say I cube plus I square plus I. So this is a multiple polynomial function, right? So pressing F5, this is a multiple polynomial function. You can make it minus also, plus, minus, and over here minus I raised to the power 5. So let's see. This is a more complex form, right? So this is how you can make use of for loop here in Matlab. So if you keep this value as 0, g input value, and actually this is a variable, so actually what is actually being executed is this statement. So if this g input, then within the bracket, if the value is 0, it will not ask for any graphical input. If I write a value as 1, it will ask for 1 graphical input. If I write a value of 2, it will ask for 2 graphical inputs, and so on. Let us experiment this also. You can uncomment this and make this value as 5. So it should ask for 5 graphical inputs. So let us see what happens. I just uncomment this also, and here I write ZZ. Now pressing F5. So here there is some error. Pause value is not there. So let us define this pause value also. Uncomment. Now pressing F5. So here you can see it is asking for a graphical input. Now I click on the screen. 1, 2, 3, 4, and 5. I clicked on the screen 5 times, and after that it moved on to the next statement where there was some undefined variable. If I change this value to 2, it will ask for the graphical inputs twice. So I again press F5. Now again it is asking me for the input, so I click. Okay, now I click here, and now it moves further after receiving 2 graphical inputs. Again I press F5. It should ask for 2 graphical inputs. I cannot click outside the graph. I have to click on the graph itself. So I click on the graph now. Now outside the graph, that is not counted. In the command window, that is also not counted. In the figure window, that will be counted. You have to click on the graph itself. Okay, now I am again turning these statements into a comment, removing this z from here and making this, okay, this graphical input as, let's say, 0. Now what I do, I press F5 here. So see, a sinusoidal graph in a distorted form, you can say a distorted form is shown over here. So here what is being done here, time axis is being defined from 0 to 100, and it is being converted into a vector form, then evaluating sinusoidal displacement signal. So what I do, I say for I equal to 1 and with an increment of 1 every time, then how much to go up to the size of t. So what is that? Size of t is, let me copy this from here, place it here, and then just press enter. Then you will learn what this command is. Size gives you the size of a matrix, right? So simply if I write size bracket round bracket t round bracket close, enter. So size of t is 11 1. 11 1 means there are 11 rows in t and there is only one column. You can see here, I type t, press enter, so I can see t vector. So there are 11 rows in this vector and one column. So that is size of the t is 11 1. But when I write size of t and I want its first variable only, so I write comma 1 and then close the bracket, enter. So now it will give me value 11. So I want to start the loop where I is 1 and every time I will be incremented through a value, incremental value 1, and how much to go till I is equal to 11. So initially this will be the first value for x, right? X11 will be sin t. t का भी कौन सा एलिमेंट 1 1, that means first value will be sin 1 1 t का 1 1, so that is 0, that will be sin 0. उसके बाद क्या आएगा x2 1, that because in second loop I will be 2 here, right? Then this will become x2 1, x2 1 will be equal to sin, उसके अंदर क्या है t2 1 and t2 1 क्या है, that is 10. So second time that will be sin 10 and so on, then it will be sin 20, sin 30 and so on. So it will keep on calculating the value and it will keep on storing these values into x. Then simply we plot the graph, plot t comma x, where t is along x-axis, the first variable is along x-axis and second variable is along y-axis, irrespective of whether the second variable name is x, y, z, y1, x1, anything. First variable will be along z-axis, second variable will be along y-axis. So for further details related to this plot command, this is a very useful command. Most of you will be using this during your ME thesis. Help plot enter. Even during the PhD thesis, this is very helpful command. Plot. So it gives you a linear plot x comma y, right? Where it will plot vector y versus vector x. That means जो वेक्टर पहले लिखा आपने यहाँ पे that will be along x axis, जो बाद में लिखा that will be along y axis. Okay, now there is another interesting plot which is a comet generated animated plot. So pressing F5. Okay. Let us increase this, reduce this increment to 1, pressing F5. Okay, let us further reduce this to 0.1, pressing F5. So this is a comet generated plot. Not so useful for your thesis purpose, but definitely helpful if you want to create something, some interesting animated plots. Okay, now self-generated animated plots in Matlab can be seen. Now pressing F5, this is comet plot, and this is a self-generated animated sinusoidal response, and the command used is, I have used plot command only, the very simple command, but the same command has been used to produce some sort of animation also. So here you can use, you can see I have used over here very basic command which is plot. So, and what I do, I plot a single point, and then I hold on the same graph, and then again calculate the next point and then plot that. Then I am basically plotting one by one all the points one by one on the same graph. So this is the self-generated, you can say, animated kind of response. Okay, if you want to draw two curves in a single plot, so this is how you can do. Okay, Control C. Now pressing F5. Okay, that this will take time. So let me press Control C here. First, let me convert these things into a comment. Now pressing F5. So these here you can see there are two plots showing two curves in a single plot. So this is the, let's say, original signal, sinusoidal signal, and then I reduce it using a multiplier factor less than 1, and then this is the reduced signal in green color, and both the signals can be plotted in a multiple signals can be plotted in a single graph also. So the method is, you give this sort of command: plot, then x-axis, comma y-axis, again x-axis, and then on y-axis the second parameter which you want to plot. Okay, then there is 3D curve plot also possible in Matlab. Pressing F5. So here you can see this is a 3D curve plot. The command used here is plot 3. So here a kind of expanded helix is there. Some values are calculated, and the 3D curve plot can be drawn using plot 3 command. Okay, then another very useful chart is pie chart, which is used by most of the research scholars. Pressing F5. So here you can see a very interesting, attractive pie chart has been drawn. So this is a pie chart showing distribution of audience in a workshop. Let's say first year, number of second year students, third year and fourth year. This color combination needs to be corrected. I think there is some issue with that legend. Okay, anyways, you can see here it is this kind of this sort of pie chart can be drawn using the command PIE3, pie3.